So the product principle or the counting principle, this is something that we can use to determine the number of ways a sequence of events can all happen together. So what the product principle states is that for a sequence of events in which the first event can occur in A ways, the second event can occur in B ways, the third event can happen in C ways, and so on for however many events you have, the total number of ways that all of the events can occur together is A times B times C, or the number of ways the first event can happen times the number of ways the second event can happen times the number of ways the third event can happen, and so on. So let's look at an example. Okay, so here we have a question where we're asking how many different 7-digit phone numbers can be made if we're just using the digits 0 through 9. First, if there's no restrictions, meaning we can put any of the digits 0 through 9 in any of the 7 positions for the digits of the phone number. Next, we're told we're not allowed to repeat digits. So this means, if our first digit is a 3, we can never use 3 again anywhere else in the phone number. And then C, if 0 or 1 can't be the first digit, and then we would assume there's no restrictions after that. Okay. So first, if there's no restrictions, right, and we want to use the product principle for this, well, first we need to figure out how many ways can we, choose each different number in the phone number. Now, this is something people often mess up. This is digits 0 through 9. There's actually 10 digits. Right, so there's 0, 1, 2, 3, all the way up to 9. There's 10 numbers in there. A lot of times people might think it's 9 sometimes, but there's 10 of them. Okay, so if there's no restrictions, well, we have 7 positions for... We have 7 positions for different numbers that we could place, right? So right here we would have our first digit. This would be our second digit. We'd have our third digit here, and so on. Right. So we have 10 possible choices for the first digit in the phone number, right? So we can use any of the digits 0 through 9, put it there. That works. Now for our second digit, they said there's no restrictions, so we can use any one of the 10 digits again. So that means there's 10 ways to choose the second digit. Right? The same thing is going to continue, right? So we can put any of the 10 digits in any of the positions, right? We could put the same thing in all 7 spots. We could put different numbers there. It doesn't matter. We can do whatever. Right? So this is going to end up being 10 to the 7th power. Now let's say that we're told repeating digits is not allowed. Right, so again, we're going to start off with 7 positions for the 7 digits of our phone number. But now we're told we can't repeat digits. So before we start, right, we can choose from any one of the 10 digits that we have up here, 0 through 9. So there's 10 choices for the first digit. Now that we've placed one in the first spot, we only have 9 digits left to choose from. So like, let's say the first digit of this phone number is 3. Now when we want to pick a digit to go in the second place, we can use any digit we want to as long as it's not 3. So now there's only 9 choices because we used one. So now let's say, we use 2 different digits over here. They can never get used again. So now we only have 8 choices left for the third digit. And now we've placed 3 digits here, so these 3 digits can never get used again. We have 7 choices left for the next one, and then 6 choices, and then 5 choices, and then 4 choices left. And this works out to be a very large number. Okay. Now let's assume that 0 or 1 can't be the first digit. Okay, so again, we would start out, we had 7 positions over here. Okay, 7. Okay, so if 0 or 1 is not allowed to be the first digit, we can choose any of the other 8 digits that are left. So any number 2 through 9, we could put in the first position. Then, if there's no more restrictions after that, it's similar to how we did the first part up here. We have 10 choices left for every other digit. So what does this end up being? 8 times 10 to the 6th power. So now let's look at this question that showed up in the video on sample spaces. So this is actually a problem that now you have the option of solving, or solving part of it using the counting or product principle instead of having to make a tree diagram. Okay. So when we were asked here, how many ways can we randomly guess on the quiz? We can solve that using the product principle. So we're told that we had a 3-question true or false exam, right? So this means that for each answer choice, you have, 2 ways that you can guess, right? So there are 3 questions on this quiz, right? And then, ways to guess. Right, so this would be for Q1, for question 2, ways to guess for question 3, right? They're all true, false, so each one has 2 choices. If we multiply 2 by itself 3 times, we end up getting 8, which ended up being how many branches we had at the end of our tree. And then for part B, if we realize, okay, well, only one of the ways that you can guess can possibly be correct, well, we could realize the answer to that is going to be 1 out of 8. If they asked us something that was a little bit more detailed, we might have to draw a tree or do something else to find the sample space. But this problem as is can be solved just using the product principle. So now let's say we're looking at another similar problem where we want to see how many different license plates we can possibly make if the license plate starts out with 3 letters coming through the letters A through Z and is then followed by 4 digits choosing from the digits 0 through 9. So we can solve this using our product principle. And in this type of problem, we would assume there's no restrictions because they didn't tell us there were any restrictions to begin with. So first, we have 3 spots for letters, and then we have 4 spots for the digits. So there's 26 letters, and we know that there's 10 of these digits. So for the first 3 positions where we have letters, we have 26 choices for each one. Then when it gets to the part where we're choosing digits to follow the 3 letters in the license plate, we have 10 choices for each digit. Okay, so now if we multiply all of these out, we're going to get a very large number. So now let's look at one more problem. So in this problem, we're told we have a Final Fantasy character. Their wardrobe consists of 3 shirts, 2 pairs of pants, 2 pairs of shoes, and 20 belts, because that's what Final Fantasy characters look like. Now we want to find out how many outfits they can make using the items in their wardrobe with different conditions in place. So first we're being told they're going to wear 1 of each item in the wardrobe. Then we're being told wearing a belt is optional, meaning they can wear it, but they don't have to. And last, we're going to look at what happens if they're wearing 1 of each item, and then they're wearing all of the belts at the same time. Okay. So if they wear 1 of each item, right, we have some number of shirts. We have some number of, what do we have, pants next. We have shoes, and then we have belts. Right, so this is a place where we can just apply the product principle. There are 3 different ways they can choose a shirt. There's 2 different ways they can choose a pair of pants. There's 2 different ways they can choose a pair of shoes. And then there's 20 choices that they have for belts. So if we multiply all of these together, we end up with 240 different possible outfits they could make. Okay. Now in part B, we're told wearing a belt is optional. So the first part of the problem is going to start out the same, right? We still have 3 choices for shirts. We still have 2 choices for pants and 2 choices for shoes. But now we need to think about how many choices we have for belts. So we have 20 belts that we can choose from, but now we have an additional option of not wearing any of them. So you can wear any of the 20, or you can choose not to wear a belt at all. So here we now have 21 choices. So you can wear any one of the 20 belts, or you could decide to not wear a belt at all. So that gives us 21 possible choices. And then if we multiply all of these together, let's see, we end up with 252 possible outfits that could be made. Now let's look at the last situation. So here we're being told they're going to wear one of each item, and then they're going to wear all of the belts at the same time. So we still have 3 choices for shirts, 2 choices for pants, 2 choices for shoes. But now when it comes to the belts, we need to figure out, well, how many choices do they have if they're wearing all of them together at the same time? So if they're wearing all of them together at the same time, there's only one possible way they can do that, and that is to wear all of them together at the same time. They're not choosing only 1 or 2, or, choosing to wear them or not wear them. It's just one possible way that they can wear all of them together at once. So there's only one possible way they can do that. And then if we multiply these guys together, we get that there's 12 different outfits they can make this way. Another way that you could think of this is if they're wearing all the belts at the same time, it doesn't matter. They don't have to choose that. They're just all there. And the only thing that they're choosing from at this point is what shirt to wear, what pants to wear, what shoes to wear. They've already decided to wear all of the belts at the same time.